Welcome to section 4.2. In this section, we're going to examine what it means to be linear and focus specifically on the slope of a linear model. So we said a model was linear if there's a constant absolute rate of change, and we called that constant rate of change, we called that the slope. So we're going to look closer at slope in this section. So let us start with a new game. All right, it doesn't exist, but I made it up. But it's for purposes of illustrating something. So instead of World of Warcraft, it's Galaxy of Warcraft, right? Bigger scale, right? And so suppose we have some incomplete data on XP for killing the same level MOB. I've now learned that MOB is monster or beast. So anyhow, let's take a look at what the data we have is, and we're going to try to figure out how much additional XP I get for kills as I change from one level to the next. So here we have some partial data. In column A, we see our character level. In column B, we see the XP we get for killing an MOB at the same level. We'd like to know how this changes as we go from one level to the next. We're going to assume it changes consistently. So one thing we might look at is first, we might want to see the changes. Oops, all right, screwed something up. That doesn't look right. We want to see the changes, there we go, that's a little better, in XP earned for a kill. Okay. So because we don't have any changes we don't have anything to change to, in order to get to 136, we don't have anything to change to, we start in our third row. Okay. So we'll just subtract the numbers in column B. And let's just drag this down. So this tells us that that as our character goes from level 3 to 7, then our same level MOB kills give us 48 more experience points. From 7 to 14 gives us 84 points, and so on. So what we'd like to think about is, what do these average out to, right, per level? So to do that, let's just look at the changes in level in our data set. So that's the difference in the A values in column A. You see those vary. And so the question is, if we average these changes over this set of levels, are we going to get the same average? Well, let's see. So average XP per level. So all we're going to do, if we're going to average them, is we're going to divide. C3 divided by D3, and it's 12. And indeed, it's 12 for all of them. So there's reason to believe that this is linear, and there's reason to believe that every level we earn results in 12 more experience points for each MOB kill of the same level MOB. We could see that this looks approximately, that we could guess that this is probably linear if we make a graph. You take a look at a graph, let me move it up, whoops. Look it out of the way. If we look at a graph, it looks linear, and indeed we've just confirmed it. But here's the important thing, right, where I want to go with this. So this linearity comes from the fact that this average over each of these portions of levels, each of these ranges of levels is the same. But how did we get those averages? We got those averages by dividing the change in XP divided by the change in the level, right? And we're assuming that while all these dots lie in a line, we're assuming that the XPs between the dots grow at the same rate, and if they do, then that rate is going to be 12 XP per level, right? And that becomes the slope. So what we just calculated in the Excel file might be best thought of as rise over run. So in this picture, we see a decreasing line, but it works the same with an increasing line, right? So the rise is the change in our Y values, our vertical axis, and the run is the change in our X values, the horizontal axis. In the example we were looking at, The y values were the XP we earned, and the x values were the levels. And when we divided the rise, which was the change over a region from, say, level 3 to 7, a change of 48, that was our rise. Our run was a change of 4 levels. When we divided, we got 12, the average change per level. So rise over run, what we're doing is we're creating a unit rate that's telling us, on average, how much does something change if we change something, how much does y change if we change x by 1? And if the function's truly linear, that's not just on average, that's true. Formulaically, you may have also seen this formula. Here, x1, y1, x2, and y2 are the coordinates of the points. Right? So this point here would have x2 equals 8, y2 equals 2. Then this point here would have x1 equals 2, y1 equals 7. And you subtract the y coordinates from the x and divide and subtract the x coordinates. Difference in y, this length is the rise. Difference in x, this length is the run. And then you divide them to get your unit rate, which tells us how much you change y by when you go to the right by 1. So here it looks like the slope is -1. Move to the right by 1, y goes down by 1. Move to the right by 1, it's a little less than 1, actually, it looks like. But that's the idea. Right? And the one thing you have to be careful about is to make sure you're lining things up consistently. Let's look at another example. In this case, we're going to look at demand, and we're going to assume linearity. Right? In other words, we're going to assume that to sell one more unit, we have to reduce the price by the same amount no matter what we're already selling. Right? Suppose we have some data. Suppose we know that if we want to sell 12,000 units of whatever good or service we produce, then we should charge $12. But we also know that if we charge $32, we won't sell anything. Right? Assuming linearity, so assuming consistent changes in the price as we change what we're trying to sell, how much should we change the price by in order to sell 1,000 more units? So I'm saying 1,000 more units because I want to measure what we're selling in thousands of units. So in thousands of units, this first number here, 12,500, that's 12.5, right? So 12.5 thousand, right? So what do? Well, up on top, the price goes from $32 to $12. 32 minus 12, that's a 20. And on the bottom, the run, so that's our rise. We drop by $20, and our run goes from selling 0 to selling 12,500. So our run is 0 minus 12.5. Notice 0 is what we sell when we charge 32, 12.5 is what we sell when we charge 12. So we calculate this, and we get negative 1.6. That's a slope. So we're assuming that every 1,000 more units we want to sell, we have to drop the price by $1.60. In the next video, we're going to take a look at what slopes look like if we don't have a linear function.